Thanks, Jim. I can see morning tea being assembled out there, so please forgive me if I rush a little bit, but I'm sure you will talk to that as well. So I'm working, key people working on this work with me are John Innes and Andy Wilson with Manaki Whenua, and Stephen, who's here this morning, will be able to answer your tricky questions. My talk this morning I've broken into two main parts. Firstly, I just want to give some background on who are the predators we're talking about when we talk about predator-free this and that, and why do we care about them, and secondly, specifically the work that we've been doing as part of the Beacon project around predator profiles and biodiversity outcomes in some of our cities. So when we talk about predators, we're talking about introduced mammalian predators. And we know a lot about them, and this is why we're concerned about them, but most of that knowledge is from forest areas, native forests and rural areas. We don't know much about them in urban context. Ecological integrity is a really useful concept in restoration and conservation, and it's a really useful goal to aim for, and it's made of three key components. One is indigenous dominance, another is occupancy by the appropriate species, and environmental representation. We know that introduced mammalian predators are bad for at least the first 2 points there. They replace native species and they replace the processes that those species carry out, things like pollination and predation and stuff like that. So native predators are actually good, and I want to keep making this point because we use the word predators quite loosely, and you'll actually be quite, there's not many restoration projects in New Zealand that would actually welcome weka, but they should be in a lot more places. We should have robins going down the necks of falcons and moorhawks. That's a good thing. We just don't want them going down the necks of possums and rats. These are the main predators we usually think about down the bottom here, these bad guys, when we talk about predator-free stuff. See if I can get the laser pointer work out. Obviously not a photo from New Zealand, it's green woodpecker, but I really like this photo because it just shows how that's a weasel attacking a green woodpecker. It's from England, and it just demonstrates how strong and bold mustelids are, and they'll take on prey that's much bigger than themselves, so very successful. That photo was a real one. I'm not touching that. Those photos, I think, are not quite so authentic. So, native predators are good, introduced predators are bad. This diagram looks like quite a lot to take in, so I'll work through it, but I think it's quite important. It's a piece of work that John and I did for the Cape City project over in Hawke's Bay, where we wanted to sort of show the relationship between the predators that are present in that system and the birds that people are interested in, the native birds. So I'm interested in the native birds first, so I actually start on the right here. For each of these birds, we worked out who are the key predators, or who are the predators, and we ranked them by their sort of order of importance. So the width of the lines is proportional to the importance of these predators. And then that all adds up on this side to give sort of a ranking overview of who are the bad guys. So you can sort of see that stoats, rats and possums come out at the top, and that's why they are the key part of predator-free 2050 work. You might also, if you look carefully, though, see that stoats are not actually the worst for many things, but they will prey on just about anything, so that's why they're so bad. Shiprats, on the other hand, are probably the worst predator for several of our forest birds. Another point here is that if you have specific birds of interest, or could be lizards, could be whatever. This is just about birds this one, but then you need to be aware of particular predators of those species. For instance, I know there's New Zealand vultures breeding on a beach here in Plymouth at the moment, or at least attempting to. So if you're interested in protecting New Zealand vultures, you really need to start thinking about Norway rats, and you need to start thinking about hedgehogs. This map, this diagram would look quite different if we did this for New Plymouth, but we don't know exactly what it would look like. predators are not well known, but they are likely to differ from rural and wilderness areas. And yet we know that domestic gardens have immense potential as sites for native biodiversity conservation. So there's a real gap there. It's got quite a hair trigger on that. This conceptual diagram just shows the relationship between predators and biodiversity benefits, the things we want. And again, I'm interested more in the biodiversity benefits, so I'll read this from right to left. We all know that basically if you want more biodiversity benefits, you probably want to have fewer predators, which will need more predator control. The problem is the links between these are not linear and they're not necessarily well known. So you can be cranking away at this handle and not actually being terribly sure of what's happening on this side. It's a bit like driving a car with rubber bands between the wheels and the steering. You're not quite sure what's going to happen sometimes. Hopefully you don't crash. So the work that we've been doing in the Pekin project falls under Research Aim 1.3, where we're going to understand and manage the unique predator profile of urban habitats. We've been working in 5 cities, many of the same cities that other parts of the Pekin work have been in. We've been working in 3 of these cities, Hamilton, Wellington and Dunedin, for the entire project. And 2 of these cities we visited just once last autumn. So in these areas we are indexing the abundance of key mammals, to try and work out what the predator profile is in these places. And we've been working in 3 environments within those cities. Residential areas, which is just people's gardens, amenity parks, and what I've called here wild reserves. Wild reserves in New Plymouth tend to be nice mature forest. In the biological desert that we call Hamilton, they might be more weedy gullies or something. But they're just less managed than, say, the amenity parks in lawns and mown and gardens are mulched and stuff. We've used tools that are safe for people and pets, and we've used consistent methods throughout the project so that we can compare between the different cities. And we've tried to have replicated treatment in pest control and non-treatment areas with no pest control. We've been measuring biodiversity outcomes, the main one of which in Hamilton has been bird nest success. We've only done that in Hamilton, and we have recent hotels in all our cities. The lizard work that Chris has just been talking about has been, it's a separate part of the Pekin project, but it has been aligned with a lot of its mammal work, so it's happening in the same places. So these are the 3 tools we've been using for monitoring. A lot of you will probably be familiar with these. They're fairly standard, and each has their pros and cons. For instance, tracking chew cards. They're very light and cheap, but the problem is they were designed for possums in forest, and if you've got lots of rats, the rats just eat the whole thing, and you don't actually know what was there before the rat came along. And they leave a nice little pile of chewed up plastic on the ground, which is not very good. It's probably one of the worst examples of single-use plastic. Trail cameras are great, but they cost around about 1,000 times as much as a chew card. We've got chew cards and tracking tunnels at each of our sites along monitoring lines. Monitoring lines are a line of 10 devices, 450 metres long. The lines have to curve around a bit to fit in our parks, so that you can have nice straight lines in forest, but we have to curve them around to fit within each of the environments. And because we've got chew cards and tracking tunnels at each site, what I've done here is just compared whether each of these pest mammals was more likely to be detected on one or the other. And you can sort of see from that, that's the bars. You can see that possums are certainly better detected with chew cards, hedgehogs and mice with tracking tunnels. Rats, maybe there's a slight edge to chew cards, but there's not much in it really. And the fact that they chew them up is particularly good. The numbers, the kappa values, I would probably need Stephen to explain exactly what those mean, but we had the cards cross-checked by different people, and that is basically a measure of the agreement between how people interpreted them. So higher numbers being better. These are sort of a summary of our monitoring results so far. There's a lot on here, but it will be on the web later, so if you're really interested, you can have another look. But these are also just preliminary numbers. The horizontal dashes are from the cameras, and the bars are tube cards for possums and tracking tunnels for everything else. All these devices are up to 6 nodes. So one of the first things you might notice is that cameras are more sensitive. They pick up more of just about everything, especially cats. Cats are purple. You only pick up the cats with cameras. We don't really detect those on anything else. Each of these seasons have got an autumn and a spring. That's an average of 2 autumns and springs for most of these cities, except for New Plymouth, which we only get once, so we've just got the one autumn there, last autumn. Unfortunately, I know there's been a lot of great work done in New Plymouth, but we still have reasonably high rat numbers. These numbers are admittedly a lot lower than you might expect to find in native forests, but they're tricky, they're not easy to control. The other thing here is you can see that Dunedin wins the prize for the most possums by far in their wild spaces. Everywhere else, possums are quite rare, scarce, and Dunedin also wins on hedgehogs everywhere. Hedgehogs are one of the more common species we get throughout. Mustardids virtually absent. There's a couple of records. We had a mustard on a ferret on a camera there, I think a stoat on a tracking card in Dunedin, as Bruce mentioned earlier. So, rats, mice and hedgehogs are most abundant in the cities. That's quite different to native forest, where we don't tend to grow so many hedgehogs, and mice maybe are more suppressed by other predators. We know we've got Norway rats and shipwrats in urban areas, and that does complicate things because they're quite different animals. Predatory 2050, for instance, just talks about rats, and everyone just talks about rats, but shiprats and Norway rats are our 2 main rat species, common rat species left in New Zealand, and they're very different animals. Shiprats climb, Norway rats swim. They both do a bit of each, but that's what they're better at. The control tools for them probably needs to differ. We tend to just throw rat control out. We don't focus on one or the other. And we can't differentiate between them with a lot of our monitoring tools. Maybe with the cameras, we're looking at that. It looks like we might be able to a bit. But otherwise, we just know we've got rats and we don't know whether it's Norway rats, which may not be a problem for some things, or ship rats. The other thing is, maybe there's a possible latitudinal trend. We haven't looked at this in great detail, but this is our cities, north to south. And maybe there's more hedgehogs as you go south, maybe fewer mice, maybe fewer rats. It's pretty early, but maybe there's something in that and it would make sense. So another part of this is the biodiversity outcome stuff that we've been doing only in Hamilton.
You've got lots of time. Lots of time left.
Lots of time. Well, I can hear the cups breaking. So we've been looking at bird nests in Hamilton. These are obviously just exotic birds, mostly, because that's what we've got in town, but we've been looking at the nest success of these species, and you can see that sort of around 40 to 60% nest success we've been getting. And that's quite sort of comparable with a couple of other studies that have been done in urban areas. And all these numbers are quite a lot higher than what we consider to be typical of unmanaged native forest, where the numbers are more like sort of the high 20s. So that could be, there's 2 things there. Could be that we're talking about more introduced species, and it could also be that the predators' sweet and abundance is different in native forest. That's what's important to understand those things. So the work we've got currently underway, we are intensifying predator control at between half of our sites, not the residential ones, but apart from maybe Wellington. looking at biodiversity outcomes in those treatment and non-treatment mix before and after. So in Hamilton, I've got a bunch of A24s out, and I've painted them black and brown to camouflage them, and so far that seems to have worked, because in the park where we didn't paint them, we lost about 30% of them, and in the park where I did paint them, they're still there, so that's pretty good. So the big project in Wellington, of course, is the Predator-Free Miramar project, which is now underway, and we've got several of our study sites in that area, so that's going to be a really useful test of biodiversity outcomes on the pest control. So to summarise, I think it's very important to identify your objectives when you're going out to do predator control. What exactly are you trying to protect, and therefore what do you need to do to achieve that? Because things like timing, the control methods, and what species you target will depend on actually what you want to achieve. I always suggest monitor the outcomes, not just the work. People like to monitor how many traps they put out and that sort of thing. But because the old rubber band is not directly attached to the wheels, you really want to be measuring some of your outcomes to know that you're actually having the desired impact. And use standard tools, or at least consistent within your project. If you want to compare with other projects, then you need to be using the same tools as other projects. If you're only interested in comparing within your own study, at least be consistent in what you do. Hopefully, by the end of this project, we'll be able to make some firm recommendations around how to monitor these things, but this work is still underway. Maybe as a preliminary guide, you could say the tracking tunnels set for one night, baited with peanut butter at the ends. That's the standard for rat monitoring in forests. So if you want to compare with those indices, that's what you should use. Extending the period of time to 6 or 7 nights, it does give you greater sensitivity, and that can be important when these days we're after, not after just reducing predators to a certain number, we're talking about predator-free and that sort of thing. So in those instances, maybe you do want to have a more sensitive detection tool. You want to have some replication in your sampling units, which are transects for chew cards and tracking tunnels. And cameras are good for just about everything. And there is a draft protocol procedure in the works that will be intended for native forests, but there may be some things in there that can be adapted to cities. And I think cameras are actually going to be probably the way that more and more of this monitoring is going to be done. And that is pretty much me. If we had 30 seconds, I was going to suggest we could watch what rats do, but I don't think we have. I'll just pump it up anyway.
I think we have time if you want.
Yeah.
We have time. I think we'd like to see.
Well, if you can make that go.
Get someone to ask a question while I play.
But anyway, you've probably seen all this sort of thing plenty of times, but I think it's always worth. Oh, you get the idea, you know. Notice the rat doesn't come in the biggest stack there in the picture. He comes in the smallest ones. Those guys, that's a ship rat, and they can climb just about anywhere. Not only does he take away a chip, but he kills all the other ones first, so that they're still there when he comes back to them later. Right, well, it's good to have a bit of a snuff movie.